Hello everyone. We will wait for 2 more minutes. If others join, then we will start. So let's start with the introduction of the participants. I think there are only two participants today. So can we start with Balaji R?
Hello.
Hello.
Hello. Hello.
Yes, Balaji, you are audible.
Good afternoon.
Good afternoon.
Good afternoon, madam. My name is Balaji. Have completed BTech in chemical engineering. Currently, I'm working as a process engineer in a water treatment company.
So thank you, Balaji. Can we move to the next participant? Kavita RJ.
Hello, ma'am.
Hi.
Good afternoon. I'm Kavita. I'm from Palakkad, Kerala.
Kavita, can you tell me how you are associated, like whether you're a student or
I'm faculty, ma'am.
okay, thank you.
Okay.
So can we move to the next participant, Karthik? Okay, can we move to Komal Chaudhary? So Komal, can you just unmute yourself and just give a brief introduction about yourself? So I think Karthik and Komal are having some network issues. So we'll move to the slides. So is the first slide visible?
Yes, ma'am.
So let's start. Good afternoon, everyone. I am Asma Parveen, one of the TA for this course. I am a PhD scholar at IIT Kanpur in Civil Engineering Department, and the course is instructed by professor from IIT Roorkee, Professor Vanu Prakash Velanki. He is from Department of Civil Engineering, IIT Roorkee. So we will first start with a brief recap of what was taught in the week 3 lectures, and then we will move to the previous year questions for the week 3, and then I have added I think 3 or 4 questions based on the material, and then this will be all for today. So let's see. So first I want to ask if anyone have any doubt till now in the questions or in the lectures. Can you, any one of you, unmute yourself and just tell that, do you know that there is one section in the portal called Ask a Question where you can ask your doubts? If you have any doubt in any question, or you think that some value is missing or some options are not correct, anything related to your assignment or lectures, you can just post your doubt there. So I hope every one of you is aware about that. So if any one of you don't know about that, then just go to the NPTEL portal, log in to, and when you will log in, you will see a section called Ask a Question. You can ask your doubts there, and also these problem solving sessions, which is conducted on Sunday or on Tuesday. The recorded video is also uploaded by the TAs. You can go and check the uploaded video, as well as you can also see the material which is being used by me and the other TA. Whatever material I am using, like whatever slides I am using, I will just I have to upload there. You can go and refer there also. And if someone have any doubt in the assignment, in the present assignment questions, you can also ask about that, but after the submission date is over. So if you have any doubt, you can ask, or otherwise we can move to the next slide.
Ma'am, we can't download videos from that. There is download option, but we can't download. There is anything to download there.
From, I think when you watch the video, there is one section which shows that you can go to the YouTube, I think, from the video,
Okay.
and from there you can download it. So I will
Okay,
check.
ma'am.
I will
For
log into the.
derivations,
Yes, yes.
which textbook should we refer?
There were 3 reference books mentioned by the professor in, I think, first week. I remember one of the book which is Water Chemistry by Benjamin Mark. I think his name, the author is Mark Benjamin. I'm not sure about that. And there were 2 more books. You can just go to the lecture 1 of the first week and you can see what are the books being referred by the professor.
Yes, ma'am, I saw, but I heard that first video lecture, but I can't get any PDF of that. Is it available to download the PDF of that textbook anywhere?
No, from the portal there is no link to download the books, but you can refer to the in your library, or you can also search for the PDF in Google. Maybe there may be the PDF is available. If not, then you have to definitely refer to your library.
Okay, ma'am.
So let's move to the questions. Sorry, to the recap of what was taught. So in week 3 lectures, first two lectures were about material balance for plug flow reactors, batch reactor and CSTR reactors. In these two lectures, you can find the derivation for each of these reactors followed by the end, whatever end equation you will get. So in examination and also in the assignment questions, the question will be based on the end equation which we get. Also, there may be chance that there is very rare chance that you will get to derive it because the assignments as well as the end exam is based on MCQs. So, but to get the essence, how to get these equations, derivation have been given. And in the third lecture, there was also a derivation followed by a question on how to find the kinetics, like how to find the order and rate constant for the reaction by using Excel. And then in the last two lectures, introduction about acid and base reactions were given, and in these lectures, application of acid and base was also introduced. And in the fifth lecture, acid dissociation constant was introduced. And also in the following lectures, that will in week 4, we will learn about visual Mintech. So sir has also recommended to download the software. So I would also say request you all to just download the software from Google. And then then in the week 4, sir will teach you how to solve the questions in VMintech. So let's move to the questions. So in the numerical question or even in the theory question, I need participation from you all. I will give you some time, just take your time. And if there is numerical based question, then if you don't have the calculator, then you must be having your mobile phones. Just do the calculation in the phone and just write whatever option or answer you are getting in the chat box. Because in the last two sessions, very less people, or I must say one or two people were participating. So I need participation from at least 50% of you. And after getting the answer from your side, then we'll move to the solution for the question. Just wait a minute. So we'll move to the first question. First question is a match the following type question in which we have to match the correct option. So these four are the terms which is given for mass balance, or I must say material balance for a reactor, and we have to find out what is V dC by dt, Qi Ci, Q naught C naught, and V Rf minus RL. So four options are given. We have to find out which is the correct option. Sorry. So these are the four options. Just take your time. I will give you all 3 minutes. Take your time and write your answer in the chat box. So the correct option is B. We'll see V dc by dt. The overall mass balance equation is V dc by dt is equal to Qi Ci Q naught C naught plus V Rf minus RL, where V dc by dt denotes overall mass accumulated in the system, that is net mass accumulated. Qi Ci denotes mass flow rate coming in. Q naught C naught is the mass flow rate going out, and V Rf minus Lf is the mass formed or consumed due to the reaction, where Rf is the formation of any component, and RL is for the loss of that component. So based on these, the correct option is B, that V dc by dt is mass accumulated, Qi is the mass flow rate coming in, Q naught C naught is the mass flow rate going out, and fourth one is the mass formed or consumed due to the reaction. So we will move to the next question. So question 2 and 3 are connected. The data is common for question number 2 and 3, and the question is, the following data provided is relevant to the next two questions. A carcinogenic compound X present in water undergoes decomposition in a completely mixed flow reactor to a simpler compound Y as shown below. So X is dissociating to form 1.1 mole of X is forming 1.5 mole of Y, and inflow water flows at a rate of 2 meter cube per day. The volume of the tank is 500 liters. The raw water contains carcinogenic compound X and compound Y with a concentration of 500 ppm and 10 ppm respectively. Assume rate constant to be 4 per day. Assume the molar mass of compound X is 0.5 times molar mass of compound Y. And we have to find out what will be the concentration of compound X in the effluent. So we have been given a CMFR, that is completely mixed flow reactor. We have been given K. We have been given the initial flow rate along with the initial concentration, and we have also been given the volume, and we have to find out the concentration of X in the effluent. So I give you all 5 minutes. Just solve and write your option in the chat box. So till now, I have not got any answer. So I'll give you a hint. I think you all don't remember the formula for the CMFR reactor. So for completely mixed flow reactor, the concentration of the compound in effluent is equivalent to initial concentration upon 1 plus K theta. K is the rate constant and theta is the hydraulic retention time, and we can find out theta using volume and flow rate. Volume to the ratio of flow rate, we have volume in liters and flow rate in meter cube per day. So we have to either convert the liters to volume, sorry, liters to meter cube or cube to liter, and we will find out the theta. So I have given you the equations. So I will give you 2 minutes to solve this and write the option. So I'm not, okay, I got one answer as C. So C is the correct answer. Let's see how to solve this. So we have been given the initial concentration of the effluent X is 500 milligrams per liter, and we have been given rate constant as 4 per day, and we can calculate the HRD using V by Q, where volume is 500 liters, Q is I guess 2. So for Q is 2 meter cubes, that is 2 into 10 raised to power 3 liter per day. So we will get the HRT as point 5 days. Next, for completely mixed flow reactor, the concentration is in effluent is calculated from this relation. We have C naught and we have K as 4 and theta as 0.25, and after solving this we will get the concentration of X as 250 milligrams per liter. So these material balances questions, for solving these questions we should know the formulas, like for CMFR this is the equation to find the concentration in the effluent. Someone asked me what is HRT. HRT is hydraulic retention time, which is the time for which the water stays in the reactor. So if we have a CMFR reactor and we are feeding the water and the time for which that water remains in the reactor is the HRT, and it is calculated from one of the formula, that is theta equals to V by Q. Is it clear or let me see. So Komal, is it clear what is HRT? Okay, thank you. So let's move to the next question. For question number 3 also the data is common and we have to find out the concentration of compound Y in CSTR after 3 hours. So let me check whether it was CSTR or CMFR. So it is, so we have to find out the concentration of compound Y in the reactor after 3 hours. So I will give you the equation for this. The equation will be same, but now we have to find out the concentration of Y, not X. So we will use the expression for finding the concentration of the X after 3 hours. The previous equation, that was C in the concentration in the effluent, is ratio of concentration in the influent to the ratio of 1 plus K theta. From this we will get the concentration of X in the effluent, and from using the stoichiometry ratios we will find out the concentration of Y. So again I will give you all 5 minutes to solve this question, but first if you get the value of X after 3 hours, just write that in the chat box and then write the final equation so that I'll get to know whether you are getting the right value for X or not. So you have 5 minutes, just solve this question and write the answers. So I got only one answer. The first part is correct, that concentration of X after 3 hours will be 333, but the concentration of Y would be different. So let's see how to find the concentration of the X. So from the previous expression, now we have been given theta as 3 hours, and initial concentration of X is 500, rate constant is 4 per day, and the HRT is given as 3 hours. We will convert into days, 3 by 24. And after solving this, the concentration of X hour 3 hours will be 333.33 milligrams per liter. And as we know from this reaction, the rate of loss of X, that is dx by dt, to its stoichiometric coefficient is equal to the rate of formation of Y with respect to its stoichiometric coefficient. Now since dx by dt is decreasing, so we will use a negative sign, and since y is forming, so we'll use a positive sign. And from this expression we can write down change of x with time, that is final concentration minus initial concentration. Since the time will be same on both the sides, so it will get cancelled out, and the stoichiometric coefficient for x is 1, and for y we have concentration at time t, that we will assume as y, and concentration at time t equals to 0, y naught, and stoichiometric coefficient here is 1.5. So after solving this, we have the concentration x naught, we have the concentration after 3 hours, we have the initial concentration of y, and we know all this, only y at time 3 hours is unknown. So solve this and you will get the answer. So I will give you all 2 minutes to put the values in this expression and write the answer. $260 is not the correct answer. So we just have to put the value in this equation. So let's see. So we do not have space. So can you just give me 1 minute to add a slide here? So the expression is concentration at any time t, here it is after 3 hours, minus initial concentration upon 1 is concentration of y after 3 hours minus concentration of y at time t equals to 0 upon the stoichiometric coefficient is 1.5. So we have to keep in mind this, that we have to consider the stoichiometric coefficient in this expression. So by simplifying, we will get x naught minus x by 1 is equal to y minus y naught by 1.5. We have initial concentration of x as 500 milligrams per liter, and after 3 hours, we calculated it as 333.33 upon 1. We have to calculate the concentration of y, and initial concentration was 10, and we will divide it by 1.5. So after solving this, we will get the concentration of y as 510 milligrams per liter. I hope this question is clear. If anyone have any doubt, you can ask, or we can move to the next question.
Solving this, we get 260 only.
Let me check. So one thing I forgot to mention, that these concentrations we have to take in moles per liter, not in milligrams per liter, because this ratio is based on the concentration, molar concentration or molar concentration. So whatever concentration we have been given, we have to convert into moles per liter. So in the question, it was mentioned that the molar mass of compound X is 0.5 times the molar mass of compound Y. So here molar mass of X is 0.5 times the molar mass of Y. So it will be 0.5 into molar mass of Y. If we consider the molecular mass of Y as YMM, so here also this is the concentration. We will divide it by molecular weight, and then after solving we will get the final concentration as 510 milligrams per liter. So it was a mistake from my side, sorry for that, because in the structure, whatever we relate the expressions for rate expressions, we use the molar concentration, not just the milligrams per liter, but we have to consider moles per liter or moles per kg or per gram. So let's move to the next question. So it is also a numerical based question. We have been given a reversible reaction. A is converting to B, and B is also converting to A. The rate constant for the forward reaction is this, and for the backward reaction is this. Initial concentration of compound A and B are 250 milligrams per liter and 150 milligrams per liter respectively. Assume the molar mass of compound A and B as 50 grams per liter and 30 grams per liter respectively. what will be the concentration of compound A at equilibrium? So we have been given the initial concentration of A and B. We have been given its molecular weight. We have been given the forward and backward reaction rates. We have to find out the concentration of compound A at equilibrium. So again, I will give you all 5 minutes. Write your answer in the chat box because there is no option given for this question. So whatever option you are getting, you just write that. Whatever value you are getting, just write that in the chat box. I hope you all remember the final expression for a reversible reaction in a batch reactor. So if you don't, then I will provide you. So I'll provide you the expression. So for batch reactors, the equilibrium concentration of A will be initial concentration of A plus initial concentration of B divided by 1 plus K equilibrium, where K equilibrium or equilibrium constant is the ratio of rate of forward reaction to the rate of backward reaction. So this is the final expression which you have to use. So take your time and write the value in the chat box. So I don't know why you are not able to solve this, because I have given you the final expression also. So should I wait for 1 or 2 minutes, or should I solve this question? Okay, okay, I will wait for 2 more minutes. So we have to find the final concentration in milligrams per liter, not in equivalent or not in moles per liter. So whatever value you are getting, just convert into milligrams per liter. So we have the expression, we just have to put the values. So concentration of A will be 250 upon molecular weight of A is 50 grams per mole, plus concentration of B is, initial concentration is 150 divided by its molecular weight, plus, sorry, divided by 1, plus we have to write the equilibrium constant, which is ratio of forward rate constant, that is 0.5, and backward rate constant, that is 0.8. So after solving this equation, the final value will be 6.154 millimolars. Now I am using millimolars because the expression is given in milligrams per liter, not in grams per liter. So for dividing in grams per liter, we will divide it by 1000, and finally the expression will be something like this: 6.154 into 10 raised to power minus 3 molars. And for removing the power, we will write the millimolars. So we have to write the final answer in milligrams per liter. So again we will multiply it with 6.154 into molecular weight of A is, I guess, 50. So the final concentration will be 307.6, sorry, will be 307.692 milligrams per liter. So I hope this question is clear. Okay, let's move to the next question. So in this question we have to solve it in Excel. So I will show you how to solve this question. This question was also discussed in the lecture 3rd. So we have been given the concentration and the corresponding, sorry, we have been given the time along with the concentration of the reactant, and we have to find out the fractional order, round off to the nearest integer for the reaction rate, for the expression for reaction, that is R equals to K C raised to the power N. So it is R equals to K C raised to the power N. Should be like this. So we have to use regression. So I will just show you the final Excel sheet. Just give me one. So I hope my screen is visible. So we have been given the time and we have been given the concentration of the reactant in milligrams per liter. So first we will find out the rate, that is dC by dt, by using the central difference formula. But for first and last values we cannot find out the central, so we will use the backward and forward difference formula. We will find out the rate, sorry, we will find out the change dC by dt, then we will find out the rate. Rate is minus rate was K C raised to power N, so we will get it as minus dC by dt, because C is decreasing, so we'll get the rate by multiplying it with minus 1. And then we will find out the model rate, that is K C raised to the power N. So first what we'll do, we will, this is the final value for K and N after using solver, but first we will assume any value of K and N. Suppose we assume the N as 0.5 and K as also like 0.7 or something. and then we will find out the rate constant as rate as k. We will use this k, and c we will use the concentration here c, and c raised to the power n, and we have assumed 0.5, so we will use the this value. And after getting the rate, we will find out the error by subtracting d and e columns. We will get the error. We will find out the square of the errors, and then we will apply solver into the summation of the square of the errors. So I hope every one of you know how to use solver. So I can also show you, but I have to change the values. So if any one of you don't know, then I can show you, or else we can move forward. Sorry. Like, can any one of you tell that should I show you how to use the solver tool? Okay. So, suppose the value of k, I will take the k as zero point 0.6, and I will use the n as 1.5. So these values will change according to that, and final error is this. So what I will do, I have already added the solver. So if you don't have a solver, you can add from the add-in. So our objective is G12. We have to minimize the error here.
Excuse me, madam. Can you share the screen, please?
Yeah, yeah, I'm sharing. So what I have done, let me remove these. So I have changed the value of k. Let me once again change it, like I will change it to 0.7, and the order, let me change it to 1. So since I have used the formula, so the corresponding rate, model rate, and the error and the square of the error will change. So now we'll go to solver. I have already added the solver in my Excel. From solver, what we have to do? We have to, the set objective is to minimize the square of the error, that is Z12, G12. We have to minimize it by changing the variables M4 and M5. So I will solve it. So I got the final k value as 0.09 and n as 1. So also we can see that the error has reduced. So we have to find out the fractional order. So we don't have to solve for k. So we got the order as near to 1.006. That will be the nearest integer will be 1. So let's see. Also, we can further reduce the value of square of the error by assuming some other values, because I think assumed n as 1 and k as 0.5. That's why I got these values, but we can assume some different value of n and k, and we can see whether the error is reducing. And finally we will take the value of n for which the error is minimum. So let's see. So the answer for this question will be 1. So option B is the correct option, that we are getting the uh, order nearest to 1. So in the lecture 3 of this week, sir has solved further. Like he has calculated the k using linear as well as non-linear regression. So you can go and see from that like how to solve to get the value of k, and how to finally come to the conclusion to which whether we have to use the linear or non-linear for regression for solving this question. So like next move to the next question. Again, it is a numerical based question. The question says, due to an accident right below before national wide lockdown due to COVID-19 pandemic, an unknown amount of benzyl chloride is introduced into a small well mixed pond that is used as a drinking water reservoir. Working for the state water authority, you are asked to estimate how long it will take until the concentration has dropped below 1 micrograms per liter. Because of the lockdown, it takes you 5 days until you are ready to make the first measurement. At this time, that is the 5 days after the spill, the measured concentration in the pond water is 50 micrograms per liter. A second measurement 5 days later shows that the concentration has dropped to 23.6 micrograms per liter. So we have to find out the time until the concentration has dropped below 1 micrograms per liter. So I'll give you 5 minutes to solve this question and write your answer in the chat box. Let's see how to solve this question. Because till now I have not got any answer. So we have been given that there is a spill, but the initial concentration of the compound benzyl chloride is not given. We have been given the 10-day and 5-day that is the concentration after 5-day and 10-day of the spill has been given, and we are asked to find out the time. Sorry, I think there is some network issue. So we have been given the C5 concentration after 5 days is given, that is 50 micrograms per liter. We have been given the concentration after 10 days, that is 23.6 micrograms per liter. I got one answer as C. Yes, C is the correct answer. So we have been given that it is a well mixed pond. So it is a CSTR system, that is completely mixed flow reactor or continuously stir tank reactor. So I got two answers as 31. Yes, 31 is the correct answer. So for CSTR, we know the concentration at any time t is related to the initial concentration e raised to the power minus kt. So we have been given the C5 and C10, that is the concentration after 5 days is, I guess, 50. Yes, 50 micrograms per liter will be initial concentration e raised to the power minus kt. We don't know k, but we know the time, that is 5 days. And also we have been given C10 as 23.6. Again, it will be related to C naught e raised to the power minus k into 10. What we can do, we can solve these two expressions. We will divide equation 1 with 2, and then we can solve, and by solving we will get the value of k as 0.15015 per day. Now we have to find out the time. So first we need to find out the initial concentration. So again, either using C5 or C10 concentration, we can find out the initial concentration. Suppose we take the C5. That is 50 equals to initial concentration e raised to the power minus k. We have the value of k as 0.015 into t will be 5 days. After solving this, we will get the initial concentration as 105.93 micrograms per liter. Now we have the initial concentration. We have to find out the concentration time at which the concentration will be below 1 micrograms per liter. So what we will do is, so final concentration is 1 micrograms per liter and lesser. So we will use the expression again. So 1 equals to 105.93 into e raised to the power minus 0.15, and we have to find out the time. So by linearizing this, by taking, like, if you take the log, then log 1 upon 1.5.93 equals to minus 0.15 t. So we will solve this and we will get the time as 31.05 days. So the correct option will be C, 31 days. So I hope this question is clear to everyone. Let's move to the next question. So we have to find out the correct options. There is more than one option which is correct. So we have to select correct options about Bronsted-Lowry acid-base theory. These are the four options. Option A is, it is a widely used theory as it applies to both aqueous and non-aqueous solution. It is applicable to only aqueous solution. Or C, according to this theory, acids are those compounds which are capable of donating proton. Or D is the option, or option D is, according to this theory, acids are defined as those compounds which are capable of accepting a non-bonding electron pair. So we have to tell out which of these options are correct. Like, more than one option is correct. So I will give you all 2 minutes to think and write your options in the chat box. Let's see. Bronsted-Lowry acid theory is applicable only for aqueous solution. So option B is the correct option. And also, according to Bronsted-Lowry theory, acid are those which are capable of donating a proton. So options B and C are correct. And also the point D, which says that acid are those which are capable of accepting a non-bonding pair electron. These are called as Lewis acid. So the option B and C are correct. So let's move to the next question. So it is a very okay. It's not a numerical question. So a particular industry needs fluoride ion in the water solution for chemical production. The source of fluoride ion available in the market is hydrofluoric acid (HF). What will be the ideal value of pH at which the industry must operate? The pKa value for HF is given as 3.17. So we have to find out of all the four pH, at which pH the industry should operate to get maximum fluoride ion concentration. So it is a pretty straightforward question. So I'll give you all 2 minutes. Just write your answer in the chat box. So the correct option is B, because HF will dissociate as H plus and fluoride ion, and we have the pKa value as 3.17. So if pH will be less than pKa value, like it is less than 3.17, then maximum of the hydrofluoric acid will be in the form of HF. But if pH is greater than pKa value, that is 3.17, then maximum of HF will dissociate and it will be in the form of fluoride ion. So since the industry needs fluoride ion, so it should work at pH greater than 3.17. So out of all these four options, only pH 7.5 is above 3.17. So option B will be the correct option. I hope it is clear to everyone. So if anyone have any doubt, then you can unmute yourself and you can ask me at any time. So let's move to the next question. We have been given the acetic acid dissociates in water as below. As below, we have been given the pKa value for this dissociation. The concentration of the conjugate base and conjugate acid present after dissociation is given. Calculate the pH of the water solution. Use Henderson-Hazel-Batch equation. So this equation says that pH is equals to pKa plus log concentration of anion to the concentration of its acid, concentration of its protonated form. So we have been given pKa, we have been given the concentration of AC minus and HAC. We just have to put everything in this formula and find out the value. So I will give you all 3 minutes to solve this question and write the answer in the chat box. Let's see, we just have to put the values. So pK is given as 4.76 and we have HAC dissociating as H plus and AC minus. So AC minus is the conjugate base for HAC and HAC is the conjugate acid for AC minus. So AC minus is the conjugate base and it is given as 10 raised to power minus 2.8 and HAC is the conjugate acid for the acetate ion which is given as 10 raised to the power minus 4.6. So after solving this we will get the pH as 2.96. So option A is the correct answer. So let's move to the next question. So we have to find out which of the following acid is strongest at pH 8. We have to assume the equal concentration of all the acids. We have been given 4 acid and its corresponding pKa value is given and we have to find out the strongest acid among them at pH 8. So I'll give you all 2 minutes. Just think about this and also write your reason for this in the chat box or just unmute yourself and just say the reason also. So let's see which one is the strongest acid at pH 8. So the lowest. Uh, Indeed, the lower value in higher the pKa value. pKa is minus log of Ka. So higher the value of pKa, it shows the acid is weaker and lower the value shows acid is stronger. But we have been given certain pH is 8. So let's see at pH 8 how this acid dissociates in water. So if we see HOCl, then it will form H plus and OCl minus, and its pK value is, K will be 10 raised to minus 5.3, and the pH which we have been given is 8. So if we see this acid, if this is the pH and if this is the pK value for this acid and the given pH is 8, it is 7.53. So if we see with the pH, the HO value will be like this and OCl value will increase and it will be like this. So at pH equal to pK, there will be equal concentration of HOCl and OCl minus. So if we see at pH 8, we have H plus and OCl minus, because maximum concentration of will be of OCl minus, because HOCl will already dissociate into its H plus and OCl minus. And if we see for other acids, its pK value are 8.63, 9.21 and 9.98. So below these pK values, all these acids will not dissociate. Like there will be some concentration of Br minus and Cn minus, but there will be higher concentration of the undissociated or protonated acid. So only HOCl will deprotonate at the pH greater than 7.53. So it will have highest H plus as compared to other three acids, and it can be used as a and it will be the strongest acid at the given pH. So I hope this is clear. Let's move to, we will solve one more question. So we have to find out the pH of a solution which has 0.36 molars of HCl, 0.62 molar of NOH, and 0.15 molar of HNO3. And since these are strong acid and strong bases, strong acids and strong base, so they will dissociate completely. So whatever the concentration of acid or base is given, it will have the equal concentration of the forming H plus and the anions. So what I am telling is that if we have HCl and it is given as 0.36 molar, so it will form 0.36 molar of H plus and 0.36 molar of Cl minus. So we have to find out the pH of the solution having mixture of these three, acid and base. So I'll give you all 3 minutes. Just take your time and write your final answer in the chat box. So let's see how to solve this question. So HCl and HNO3 will dissociate and will give H plus along with the anion, and NOH will dissociate and will give sodium ion along with hydroxide ion. As we know that OH minus combines with H plus to form H2O. So we have some amount, some concentration of H plus and some concentration of OH minus. So uh, from this we will get the concentration of H plus as 0.36, because each mole of HCl will give 1 mole of H plus and 1 mole of chloride ion, plus 0.15 because 1 mole of HNO3 will also give 1 mole of H plus, and it will be 0.51 molars. And if we take OH minus, then from NOH we will get 0.62 moles or moles per liter of OH minus, and each mole of hydroxide can react with each mole 1 mole of H plus to give 1 mole of H2O. Sorry. Yes, yes, that's right. So out of this 0.62, 0.5 molar of OH minus will already react with 0.51 moles of H plus to form H2O. So we will have OH minus remaining as 0.62 minus 0.51, that will be 0.11 molar. And we know that pH is minus log concentration of H plus. So we can convert this OH minus into H plus, or we can find out POH, or we can subtract it from 14 and we will get the pH. So if suppose, let's convert the concentration of OH minus into H plus. So as we know from this expression, Kw equals to concentration of H plus into concentration of OH minus. So the concentration of H plus will be Kw, and Kw at 25 degrees centigrade is 10 raised to power minus 14, to the concentration of OH minus, which is given as 0.1.11. And we know that pH is minus log concentration of H plus. So after putting the value of H plus, that is 10 raised to power minus 14 upon 0.11, we will get the pH as 13.04. So 13.04 is the final answer. So this was the last question. If you have any doubt or any suggestion, then you can unmute yourself and you can say, or otherwise we will end this session. Also, I will suggest you all to please download the Visual Mintic software for the next week lectures, because I think the assignment will also be based on solving the problems in Visual Mintic. So it will be very convenient if you all have the Visual Mintic software already in your system. So if you have any doubt, then you can ask me, or otherwise we will end the session here. So I think no one have any doubt. So thank you so much for joining. Have a nice day.
Thank you, ma'am.
Komal asked me, please provide the link and also tell from where we can access the previous lectures. Which previous lectures, Komal? Komal, can you unmute yourself and just tell me what lectures you are telling about?
Hello.
Yes, Komal.
Hello.
Yes.
Ma'am, the lectures that you have taken before, like earlier before these lectures,
Okay.
I have joined this is my first class, so I need previous lectures to get into the
So
subject.
first, this is not any lecture. It is just a problem solving session where we are discussing the questions related to the material for every week. So in the NPTEL portal, there is one section at the bottom left. I don't remember the name for that section. I think this is problem solving sessions. From there, you can find out the YouTube video. This video will be uploaded in the YouTube, so you can find the video also. And also, we are uploading the content, whatever content we are using here. You will also find a Google Drive link from where you can download these slides also. So I hope.
Okay, ma'am.
Okay.
Yeah, ma'am, I get it. And the software that you were talking about.
Visual Medtech, yes.
Okay, okay.
So you can
Okay,
Google
ma'am.
it,
Thank you
and
so much.
I think if you will Google it, Visual Medtech, then it is a free software to download. You can download it and you can set up. It is only supportable in Windows, I think. So you need to have Windows. You can download the software, and then in the coming lectures, sir will tell about how to use that software and how to solve the acid-base problems in that. So I think.
Okay, ma'am. Thank you so much.
Okay,
Yeah.